Okay, so this is where we stopped last time. And what we did was we identified the signs of the trigonometric function in each of the quadrants. Now, when you read the quadrant, you start with the rightmost, okay? And then think of the letter C. Why is it white? And then you just think of the letter C, right? So when you write C for coordinate, right, this is where you start. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And usually the best way to remember the signs SIGN of the functions in each of the quadrant would be all students take calculus, meaning in the first quadrant, A stands for all, okay? So all the trigonometric ratios would be positive. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. All right, so all students take calculus. That's one way to remember it. Now, let's look at a triangle whose equation is centered at 0, 0. Do you remember your triangle equation, circle equation, right? You have x squared plus y squared equals r squared. So this is basically the equation of a circle. The center of the circle is at 0, 0. That's why we have simplified it this way. And this also reminds you of the Pythagorean theorem, right? This is also the Pythagorean theorem. So if you have a circle, okay, the hypotenuse represents the radius of the circle. The hypotenuse is the radius of the circle. This distance here, which is y, is the opposite side of the angle. We call this the central angle. And the x, the distance x, it's okay. The distance x is the adjacent side, okay? So we can use the reference triangle to evaluate the trig functions of any angle. So remember, y is the opposite side. Y is the opposite side. X is the adjacent side. And r, the radius, is your hypotenuse. Okay? So remember your SOHCAHTOA? So using y, x, and r, sine theta would be opposite over hypotenuse. So opposite is y, hypotenuse is r. So this would be y over r. Okay? And so therefore, its reciprocal, which is cosecant, would be r over y. All right? Now, cosine is adjacent over hypotenuse. Our adjacent is x, and the hypotenuse is r. So cosine is x over r, and its reciprocal, which is the secant, would be r over x. Okay? Then your tangent theta is opposite over adjacent, TOA, opposite over adjacent. Opposite is y, and the adjacent is x. And therefore, its reciprocal, which is cotangent, would be x over y. All right? So let's apply that right here. Let's look at this problem.
Miss, could you go back, please?
Back. Okay.
You can go ahead.
Okay. All right. So let's look at this example. So if tangent theta is 5 over square root of 11 and theta is in quadrant 1, find the following ratios. So let us say, because your theta is in quadrant 1. So let's say this is your theta. Okay? That's your theta because it's in quadrant 1. Now let's form our right triangle here. Okay, tangent is opposite over adjacent, right? So this is your opposite. This is your adjacent. So your opposite side is 5 and your adjacent side is square root of 11. All right? So we want to find this side, the hypotenuse of the triangle or the radius of the circle. So remember your formula, right? You have x squared plus y squared equals r squared. Okay? Now tangent theta is equal to y over x, right? As we have established earlier, which means that your y is 5 and your x is square root of 11. Okay, so let's plug this in here to find r. So we have square root of 11, that's your x. We square that. And then your y is 5. Square that is equal to r squared. Okay? Now, square root of 11 squared is 11. 5 squared is 25 equals r squared. Okay, we're just doing the math here. 11 plus 25 is 36 is equal to r squared. So what would be your r? By the way, r, which is the hypotenuse, we said is always positive, okay? Right. So your r is equal to 6. Now remember this. This is your y. This is your x. This is your r. Okay? So sine theta, sine corresponds to y. Okay? Sine corresponds to y. So sine theta is y over r, which is 5 over 6. Let me write down right here. So sine theta is y over r. Cosine theta is x over r. Okay, and these are just the what do you call this? Reciprocals. Okay, so cosine theta is x over r. Our x is square root of 11 over r, which is 6. Okay, now cotangent theta is the reciprocal of tangent. Your tangent theta is 5 over square root of 11, right? So the reciprocal of 5 over square root of 11 is square root of 11 over 5. Secant is the reciprocal of cosine. Now, good news. I will not ask you to rationalize the denominator. Okay? So this would be equal to 6 over square root of 11. We can just keep it that way. And cosecant would be 6 over 5. Did you get it? Question? Okay, let's have the next one. I'm good to go, class? Still copying? Still thinking of questions to ask? All right, let's look at the second example. Okay. So be careful that you read the given, all right? So it says here sine theta is 3 over 5 and theta is in the second quadrant. So let's try to draw that. Theta is in the second quadrant, so somewhere here. Okay, this is where your theta is. It's in the second quadrant. Now, you're given sine theta. And sine theta is y over r, right? Sine theta is y over r, which means that if sine theta is 3 over 5, we can say that your y is equal to 3 and your r is equal to 5. Yeah, the quadrant would always be given to you. The quadrant would always be given. So you have y is equal to 3 and r is equal to 5. Okay? So what's missing here? We want to find the, you have y and r, we need to find the x. Okay, so let's find the x. Let's use our Pythagorean theorem. X squared plus y squared is equal to r squared. Okay, so we're missing the x. X squared plus y is 3. So that's 3 squared equals r is 5. So you have 5 squared. Okay, so simplifying this, 3 squared is 9. 5 squared is 25. We subtract 9 from both sides. So you get x squared is equal to 16. So what would x be equal to? Okay, you have a positive. Remember when you get the square root, it's either positive or negative, right? So the square root of x squared, the square root of 16 is either positive 4 or negative 4. All right. Now question. Where is quadrant 2 again? Where is quadrant where is theta again? What quadrant? Second quadrant, right? It's in quadrant 2. What is the sign SIGN of x in the second quadrant? Positive or negative? In the second quadrant. What is the sign of x? It is negative, right? Why do I have to? So here, your x is negative and your y is positive, correct? That's why your sine is positive and your cosine is negative, okay? So we have to use x equals negative 4. Got it? That's why the quadrant where theta is, the terminal side of theta is, it is important because it tells you the sign of the x and the y. Okay? So from here, okay, let me just write down the given. So we are given that sine theta is equal to 3 over 5. Okay, it therefore follows that secant theta, not secant, cosecant. Reciprocal of sine is cosecant. So it follows that cosecant theta would be equal to 5 over 3. Okay? And then you have cosine theta. Cosine theta is x over r, right? Your x is negative 4. So that's negative 4 over r. Our r is 5. And so therefore, your secant theta, which is the reciprocal of cosine, would be negative 5 over 4. Okay? Then we have cotangent theta. Cotangent is y over x. So our y is 3 and our x is negative 4. Okay? Oh, what? What is going on with me? This is tangent. So tangent theta is 3 over negative 4. Forgive me, class. And so therefore cotangent theta would be negative 4 over 3. Ask your questions, class. So you should know all three, the x, the y, and the r. Okay? You would always know two of them. You'd always know two values. You have to find the third value. And you know, r is always positive. Okay, r is always positive. So there's no question about it. Now, the sign of the x and the y would depend on the quadrant where the terminal side of theta is. All right? So let's move on to the next one. Okay. So here, we are given that tangent theta is 15 over 8 and theta is in quadrant 3. So this is the third quadrant. This is where your theta is, the whole thing. Remember, when you measure, you always start with the positive x-axis. That's always the initial side. And the vertex is always at the origin. So this is where your theta is, okay? That's theta. That's your in the third quadrant. We are given that tangent theta is 15 over 8. And we know that tangent is y over x, right? Tangent is y over x, which follows that therefore that y is equal to 15 and x is equal to 8. Okay? So here we are missing the, oh, okay. I'm missing something here. Theta is in the third quadrant. So your x here would be negative and your y would be negative as well, right? X is negative and y is negative. So I will prefix the negative sign into the x and the y because anyway, negative divided by negative would still be positive. Negative 15 divided by negative 8 would be positive 15 over 8. You follow? Okay? So your y is negative 15 and your x is negative 8. So we're missing the r. Let's solve for r. You have x squared plus y squared is equal to r squared. Okay? All right, so we have negative 8 squared plus negative 15 squared is equal to r squared. What is negative 8 squared? 64, positive, right? The square of a negative is positive. What is the square of negative 15? 225, right? And then 64 plus 225 is 289, right? Is 289 a perfect square? What's the square root of 289? 17. Yep. And we know it's plus or minus as well. But since this is the radius is always positive. So we'll only take the positive root. Okay, so r is 17. Your y is negative 15. And your x is negative 8. Okay? So from here, I want different colors. So we have, let's set it up. Sine theta, cosine theta, tangent theta is given. And then you have your cotangent theta. Okay, cotangent theta, secant theta, and then cosecant theta. All right, let's set this up. So we are given tangent theta is 15 over 8. So let me just write it down here, which means that your cotangent theta would be 8 over 15, the reciprocal, right? Now, sine theta is y over r. So this would be negative 15 over 17, okay? Cosine theta is x over r. So you'll have negative 8 over 17. So secant theta would be negative 17 over 8, the reciprocal, and cosecant is negative 17 over 15. Okay, class? All right, why don't you try the next one? Oh, now this one, the terminal side is not given, okay? But you are given the point 1 square root, negative square root of 3, which means that your x is positive and your y is negative. So in which quadrant do you have a positive x and a negative y? In quadrant 4, right? So it's letter D. Your theta would be in quadrant 4, okay? Because your x is positive and your y is negative. So if the quadrant is not given, it gives you the sign of the x and the y. So you'd know what quadrant, all right? So why don't you go on ahead and do this one? Let me time. 2 minutes, okay? Plus. Okay, by the way, class, while you're doing this and you're listening to me, about the course recommendation for next school year, I'll be putting in the recommendations by tonight. Okay, we're given the deadline until tomorrow, and there have been some changes about how the recommendations would go. So I'll be inputting the recommendations on Synergy tonight. Okay, we just have to have another meeting with my group. um, if you if say I recommended you to intro to stat, right? But you want to go to AP Calc, just for example. So that's leveling up. I will, you have to tell me because I will have to send you a form, okay, for you to change the recommendations, okay? But if I say recommended you for AP Calc, and you say I cannot probably do AP Calc, I want to do stat or business calculus or whatever lower level, okay? Then you just have to talk to your counselor. So if you're leveling up, you have to get a form. If you're leveling down, you just have to talk to your counselor. Make sense? Sophia, your brother? Yeah, after the recommendation. So you have to tell me so I can send it to you. Okay, so we're done. All right. So can somebody dictate the answer to the class? So we are missing here the R. What did you get for R? 2. R is equal to 2. Did everybody get 2? Yes. Okay, so what is sine theta? This is your x and this is your y. X is 1, y is negative square root of 3. So that would be negative square root of 3 over 2, right? Cosine would be 1/2. Tangent would be negative square root of 3. Cotangent would be negative 1 over square root of 3. Secant is 2. And cosecant is negative 2 over square root of 3. Did everyone get this? Yes? Yes? Okay. So with, type in your chat, what do you think, how you feel about the lesson today? Yes. Yeah, I can go a slide back. We still have some B's. Okay, what I'll do, if you're answering B's or C's for this one, okay, what I will do is I would prepare a Desmos self-checking activity again for this one so you can review, okay? So, and that would not be graded. That is if you are telling me that you still need some help with this, okay? Or you're still a little bit confused, I will design a Desmos activity so you can self-check, okay? Okay. All right. So let's go back. Thank you for that input. Let's go back to your module. You just have finished day one. So we're going on to angle conversion. So let's go to day two. This is quick. Angle conversion and coterminal angles. Where is it? Angle conversion and coterminal angles. All right. So as I have, are we all in here? Okay, so as I have promised last time, There are several B answers to the reflection. And, wait, all right. No, not this one. It's this one. And I'll just go back up. So this is slide number 4. Oop. Now there was some confusion with this one because my mind was floating. So anyway, remember this is your special right triangles. Okay, ready for this? Special right triangles. So the first one, you have a 45, 45, 90 triangle. This is an isosceles right triangle. Okay, so this is also 45 degrees. And do you remember what the ratio is? What ratio we are using for 45, 45, 90? 1 is to 1 is the square root of 2, right? 1 is to 1 is the square root of 2. So all you needed to do is to multiply this by x. Now, x represents the leg, the shortest side. In other words, x represents the shortest side in a right triangle. So in this particular case, your x is equal to 8. Your x is equal to 8. So if you're multiplying this by x, then it would be x is to x is to x square root of 2, right? Now with your x being equal to 8, then the sides would be 8, 8, and 8 square root of 2. So this would be 8. This other side would be 8 as well. And this other side would be 8 square root of 2. All right? Now let's look at the other one. So the second one is a 30, 60, 90 triangle. So this angle here is 30 degrees. All right. So you have a 30, 30, 30, 60, 90. What's the relationship here? What's the ratio for 30, 60, 90? Okay, 1 square root of 3 and then 2, right? Now, x is the side opposite the 30-degree angle. So if you're multiplying everything by x, okay, what are we given? We are given the hypotenuse. This is the side opposite the 90 degrees. This is what's given in the figure, okay? Which means that the 10 is your 2x. This is x. This is x square root of 3, right? So the side opposite the 30 degrees is your x. The side opposite the 60 degrees is your x square root of 3. And your hypotenuse is 2x. Which means that 2x is equal to 10, right? Therefore, your x is equal to 5. Okay? So if x is equal to 5, then this side opposite the 30-degree angle would be 5. This side is 5 square root of 3. One more. Okay. All right. Supposing we are given this. You have a right triangle, 30, 60, 90, and you are given the side opposite the 60 degrees. Okay, so again, you have 30, 60, 90. Ratio is 1, square root of 3, 2, right? Which means that, okay, so we're multiplying that by x, which means that the side opposite the 30-degree angle is x. Side opposite the 30-degree angle is x. The side opposite the 60-degree angle is x square root of 3, right? And the side opposite the 90-degree angle is 2x. So let's utilize the given. From here, you are given this side, and that side is x square root of 3. So x square root of 3 is equal to 7 square root of 3, right? If you divide both sides by square root of 3 to get x, then your x would be equal to 7. That's correct. So your x is equal to 7. Therefore, this side is x, that's 7. And this side would be 2 times x. This side would be 14. Make sense now? Hopefully it does. Okay, so I'm moving up because we have discussed reference angle from last time. Okay, if you remember reference angle. Again, reference angle is this acute angle formed, okay? Acute angle formed, meaning less than 90 degrees, between the terminal side and the x-axis. So the reference angle, let me just write it down. Theta sub r is the acute angle between the terminal side of theta, terminal side of the angle, and the x-axis. So let's look at the following. Oh, they used theta prime for the reference angle. Okay, so that's okay too. Theta prime. All right, so let's first draw the angle. So for the first one, your theta is 135 degrees, right? Now we know that this is 0. This would be 90 degrees. That's the right angle. And then another right angle, so that's 90 degrees plus 90 degrees would be 180 degrees. And then 180 degrees plus another 90 degrees, that's 270 degrees. And then 270 degrees plus that right angle again is 360 degrees. Okay, so these are the angles for each end of the axis. Okay, so you have 0, 90, 180, 270, 360. All right. So 135 is between 90 and 180. It doesn't have to be precise. So your 135 degrees would be somewhere here. All right. That is your 135 degrees. Now the reference angle is the angle between that terminal side and the x-axis. So your reference angle is right here. This is our, let's use theta prime. Okay, this is your theta prime. That's the reference angle. So how do we find this small angle right here? What do we have to do? Remember, this whole thing is 180 degrees, right? We only want this portion. Okay, we know this to be 180. So we need to eliminate this part. Yes, so that would be 180 degrees minus 135 degrees. This would remain. And that's equal to 45 degrees. right? Okay, what about the next one? 210. So 210 is between 180 and 270. Okay, it's between 180 and 270. So let's say this one. Okay, this angle is your 210 degrees. Your reference angle, going back to the definition, is the angle between this terminal side and the x-axis, which means that this is your reference angle. It's always the angle between the terminal side and the x-axis. So this is our theta prime. Okay? So how do we find theta prime? We know this to be 210. The whole angle is 210. We only want this. Okay, we only want this part, which means that we need to eliminate this. Okay, we need to eliminate this. So what do we have to do? Yes, 210 degrees minus 180 degrees. This side here is 180. You want to eliminate that. You want to take that away so that you'll only have this part. So theta prime would be equal to 30 degrees. Are you following? Okay, now let's look at the next one. 300 degrees. Now this is 270. This is 360. So 300 degrees is between 270 and 360. Say this one. Okay, this is our 300 degrees. Okay, the whole thing. Now, the reference angle is the acute angle between the terminal side and the x-axis. So this is your reference angle right here. Okay, that's our theta prime. So how are we going to get this angle if we know this to be 300 degrees? We want to find this. Yes. So theta prime, very good, Sophia, is 360 degrees, that complete angle. And then you have to take this out, okay? The whole angle, and then you have to take this out so that this would remain. So 360 minus 300 degrees. So the reference angle is 60 degrees, okay? And then the fourth one, theta is 60 degrees. So 60 degrees is between 0 and 90, right? So it will be right here. This is your 60 degrees. So what is your reference angle? Do we need to do anything here? Nope, because it's in the first quadrant, right? This is already an acute angle. This is already less than 90 degrees. And this is the terminal side. So going back to the definition of reference angle, it's the acute angle between the terminal side and the x-axis. The terminal side is where because your initial side is always the positive x-axis. Okay, so when you measure the angle, wherever that line is, okay, wherever that measurement is, that would be your terminal side. So like in this case, we want 135. So when you measure the angle from the positive x-axis, where do you stop? You stop somewhere between 90 and 180 because 135 is between 90 and 180. So you stop right here. You terminate here. Okay, that's why it's the terminal side. Okay? All right. So let's look at this. If the angle is positive, remember in trig you have a positive angle and a negative angle. If the movement is counterclockwise, that is positive. If the movement is clockwise, that is negative. All right? So here, we have all positive angles. So if the angle is in the first quadrant, is in the second quadrant, your reference angle would be equal to 180 degrees minus whatever that angle is. Okay? And then if your angle is in the third quadrant, your reference angle would be equal to that angle minus 180 degrees. Oops. So this switches. If the angle is, if the terminal side is in the fourth quadrant, then you have to use the 360. Okay? So your reference angle would be equal to 360 degrees minus whatever that theta is. And if the angle is in the first quadrant, the reference angle is the same as the angle. Okay, so again, this is how you find the reference angle so long as the angle is positive. All right. Ten minutes, 10 minutes, 10 minutes. Any question here? All right. Now let's do the conversion. Now this is easy. Conversion. So what we want to do is we will convert angle measures from degree to radian. Radian is another measure. This is where you have the pi. Okay. So the degree is where you have the degrees, that symbol for degrees. For radian, we have to use the pi. Okay. So we are converting from degree to radian and then from radian to degree. And then let's see if we have time to find coterminal angles. Okay. Now, your conversion factor, if you have this, okay, one complete revolution is equal to 360 degrees, right? Okay. And one complete revolution is also equal to 2 pi because the circumference of the circle is 2 times pi times r, right? So if the radius is equal to 1, then one complete revolution would be equal to 2 pi. So 360 degrees is the same as 2 pi. If you divide both sides by 2, then you will have this conversion factor. Pi is equal to 180 degrees. So when you are given degrees and you want to convert it to radian, just multiply by pi over 180. The purpose here is so that the degree cancels each other out. And if you are given a radian measure, to convert it to degree, you just flip this. You multiply by 180 degrees over pi. So the purpose here this time is to cancel out the pi to leave you with the degree measure. Okay? So let's look at some examples. You have here 300 degrees. We want to convert this into radian. So we want to cancel out the degrees, right? Therefore, we need to multiply this by pi over 180 degrees. So these degrees here, the unit degrees, would just cancel out. Okay, and what you want to do is to multiply. So you'll have 300 pi over 180. And you want to reduce this to lowest term. Do you know how to use your calculators to convert to lowest term? So you just divide 300 divided by 180 and then math and then enter. So that's 300 divided by 180 and then the math button in your calculator and then press enter twice. And what do you have? What is, we're just do not include the pi, just the numbers, 300 divided by 180. What'd you get? What you get? What you get? 5/3. So you have 5/3, right? That's your 300 over 180. Then don't forget to put in the pi. Okay, so this would be 5 pi over 3. We want this in fraction form, not decimal. Okay, so the 300 over 180 in lowest form. Okay, what about 210 degrees? So again, we need to multiply this by pi over 180 degrees. So the degrees would cancel out. You will have 210 over 180. So again, in your calculator, divide 210 by 180, and then math, enter, enter. 7 over 6. Are you all getting this? So 210 divided by 180 in lowest term is 7 over 6. And then just don't forget to add in the pi. Good? Okay. Told you this is easy. Easy. All right. Now, this time, let us convert from radian to degrees. So when you convert from radian to degrees, you want the pi canceled out, right? So we will do 180 degrees. We multiply by 180 degrees over pi. So the pi cancels out. And you just put this straight into the calculator. 5 divided by 4 times 180. Or 5 times 180 divided by 4. What do you get? You can do 5 divided by 4 times 180. Will that work? Yeah, 225 degrees. Okay. Now, what about 2 pi over 3? So we multiply this by 180 degrees over pi. Again, that pi cancels out. So you have 2/3 times 180, which gives you 120 degrees. Questions, class? Yep, I guess this is the easiest of the topics we have discussed so far today. All right. Okay, we have just 2 minutes left. Let's see what can be done here. Okay, so coterminal angles. Coterminal angles are angles in standard position. When we say angles in standard position, the vertex is at the origin, the initial side is on the positive x-axis. So we're just looking at the terminal side, all right? Okay, so coterminal means they have the same terminal side, all right? So say this angle is 60 degrees. Now, what we want to do is to find two angles, one positive and one negative, that is coterminal with 60 degrees. So one positive angle coterminal with 60 degrees means you have to do one complete revolution and then stop right there, because positive is counterclockwise, right? So this would be one complete revolution is 360 degrees. That's this part. And then you have to add this. And this is equal to 60 degrees. So 360 plus 60. Yeah, so that would be 420 degrees. They are coterminal because they have the same terminal side. All right? Now for a negative angle, you go in the clockwise direction, right? So from this initial side, we go in this direction. So do not forget to put an arrow so I know which direction you're going. So this is the coterminal angle. How do we find this angle measure, knowing that this is 60 degrees? Anybody? That would be 360 degrees. You want to take all this one complete revolution and take this out, just like your reference angle, right? So 360 minus 60 degrees, that would be equal to 300 degrees. And it's negative. That would be negative because you are going in the clockwise direction. All right, so that's negative 300 degrees. Okay, so probably you can try to do the radians. Same thing. Okay, you are given 7 pi over 6. You want to find a positive coterminal angle and a negative coterminal angle, knowing that one revolution is equal to 2 pi. Okay? Okay, dokes? All right. So we'll stop right here and we'll pick up from this slide on Monday. No, we don't meet on Monday. We meet on Wednesday. We meet on Wednesday next week. So on Wednesday, we'll start with this and I will have to bring down um, that other lesson for week 3. All right. I am available today 2:45 to 3:15. If you're interested to come, yes, there's no school on Monday. It's President's Day. So have a safe weekend, class. Stay safe.
Have a
See
good
you
weekend.
Wednesday.
Bye.
Bye.